So got a good day today. We are going to prove triangles are congruent using the S and the SAS. Side, side, side. SSS is side, side, side. And we're going to use something called side angle side. So let's refresh though. Before we attack this, we need to remember what the definition of congruent figures were. What did we have to prove in order to show that triangles were congruent? Congruent triangles are triangles that have congruent sides and congruent angles. Now, when we think about it, that is a lot. Why? Because there are 3 pairs of congruences here. I have to prove that, either given or parallel lines or whatever. And then pairs of angles, 3 pairs. So that's 6 things I have to write down. 3 pairs of sides and 3 pairs of angles. Of course, as mathematicians, we always ask, is there an easier way? Is there a simpler way? And it turns out that there is. And another triangle here. TMZ. Then what we end up having is, notice we have to mark it, right? So this AB is congruent to the MT, the BC and the MZ, the AC and the TZ. So what we can conclude here is that triangle ABC, and notice that if I keep this order, I have to go create the order over there, start at the T, M, and Z. So the only thing we know are the sides being congruent. And our conclusion is that the triangles themselves are congruent. All right, make that change, please. 3 sides of one triangle are congruent to 3 sides of another triangle. Oh, I get too excited sometimes. So side, 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 hence the name, side, side, side. And we simply just call it side, side, side. Or sometimes it's called side, side, side triangle congruence. If 3 sides of one triangle are congruent to 3 sides of another triangle, then the triangles are congruent. Again, this is the reason why your house stays up. If you have your studs put up there, and so this is a wall, notice what could happen. The entire house could shift, something like this, and everything just shift like that. So what they have to do, of course, is every so often you see a brace that goes across there, and it would stay in place. So the next part is going to be called side, side, side. Or excuse me, side, angle, side. And this is how, I know, I didn't have enough coffee this morning. And it reads like this. If 2 sides of one triangle and the included angle are congruent to 2 sides and the included angle of another triangle, then the triangles are congruent. How come it's not working? If 2 sides and the included angle of one triangle are congruent to 2 sides and the included angle of another triangle, then the 2 triangles are congruent. I encourage you again, use the symbols like triangle there, use the symbol here for angles, use the number for 2, just to speed your writing up. All right, so by way of observation, we notice that we have not mentioned much, or if at all, what's called the included angle. So it looks like this. The included angle is the angle that's, in the sense, between the 2. All right, so let's see what included angle means, and it's best by way of a diagram over here. So we're going to draw some sort of triangle. Again, it doesn't matter. Mine just happens to look like a right triangle. It doesn't have to be right. The important part is not that it's right. The important part is that we have stuff that look alike. So this says this side, so here's a pair of sides, and here's a pair of sides. When I say included angle, which angle do I mean on the very first one? And that's a D, E, and an F. This is my included angle right there. And I'm not going to mark it as a right because it's not necessarily right, which means I have to also mark this included angle. And so I will just have VWU over there. So if all this is true, I have 2 sides and the angle that's kind of in between, that's included, and 2 sides and the in between over there. Then I know that triangle DEF, and here I established the order. So let me just make sure I follow it. D starts with the congruent angle for no particular reason. Then go along the double to the E. So start at the included angle. So over here I have to say W, triangle W, go along the double to get a U, and the last one is a V. Just by way of a non-example, if we had something that looked like this, and this is just a quick sketch, but I had that included angle there and just going completely not to scale here. But what if I had that scenario? If I had that scenario, notice here, this is the side angle side, right? Pair of sides, pair of angles, pair of sides. So in terms of order, that's would be a side here. So this would say, oh, there's a pair of sides, there's a pair of angles, there are a pair of sides. But over here, this is a pair of sides, that's a pair of sides, and that's a pair of angle. Or that's an angle. So in that case, this order matches, but this one doesn't match. So the best we could say is, I don't know. We don't know if they're congruent or not. They might be, but we don't know. So this would be kind of a non-example of the situation. So let's look at this next one here. It says, for each triangle, name the included angle between the pair of sides given. Well, if you have a triangle MAT, notice we're asked, here's a side MT and a side TA. What letter is repeated in those two sides? Just shout it out. T. So T is your included angle. Angle T is where the included angle is. Why? Because of course the sides share that vertex. The sides share that vertex. Notice my error. I should have been more specific. Not just T, but angle T is best in how to write that. Practice. See if we have right now. Now, by the way, when we are asked if triangles are congruent, we have three answers. One answer is we could say that yes, they are congruent, and we'd give a list. Another answer is no, the answers aren't. The triangles are not. The other way to say is we do not have enough information. Not enough information. That's another way of saying IDK. Now, IDK is not because I don't know anything. In this case, it's just saying I honestly don't have enough information. So it's yes, no, and maybe. So maybe is an option. In fact, maybe will be the option if something doesn't work. Because we're like, well, it could be. We just don't know right now. All right, so let's take a gander here at number 5. We are told we have two triangles. We do not know if they're congruent. But let's see. We have one pair of sides congruent there. We have another pair of sides congruent there. And do we have anything else that's congruent? Awesome sauce. WY is congruent to itself. So I can actually put a triple on that one. So if I'm looking at this triangle right here and this triangle right here, it turns out the triangles are congruent. So what would my answer be? It says which triangles are congruent, and we can say that triangle WXY, and again, it doesn't matter the order. I just have to pay attention that I follow the same order on the other one. I went W along the single, along the W, or excuse the double, WXY. So here's the single, YZW. Triangle YZW. So notice it's not necessarily alphabetical order. But what's the reason we're using? The reason is the side, side, side postulate. And you can simply just say that. Another possible answer you could say is not enough information. Okay? So on this one I can mark AE as congruent to itself. Follow the pattern here. Let's see. This one here is an angle. This is a side here, and that's a side there. So what's the pattern we're following? Are we using the included angle here? And the answer is, angle, side, side, or if I read the other way, side, side, angle. But notice I don't know anything about this angle here, which would make it side, angle, side. So the answer here, not enough information. The answer is, I don't know, I can't determine, maybe. Okay? And that's good. At this stage, we just don't know. We don't have enough information. So on page 2 here, let's actually work through the proof. What you did before was not a proof because you didn't write everything down. What you did was just shorthand. So what we're going to do is walk through step by step and how to formalize it. Now again, This is very low-key. The first ones are, because most of the stuff's just given to us. So later we're going to have to unpack, like with parallel lines or vertical angles, etc. So in this case here, what do we know to be true? We know all this is true up here, and we know PQ and ST. So what we're going to do is, as I go, even though things are marked over in the triangles, I'm going to mark them again. So step number 1, I'm going to say that NP is congruent, and let me choose one from over there. So NP, so we update that real quick just to make sure our letters are good to go. All right, so NP, to what does NP probably correspond? NP over here, and so SR maybe, or it flips, we're not exactly sure, but here's my pair, SR. Now there are actually 2 reasons for that. Number 1, since this is not specifically said up here, it's kind of like the transitive property or given. So if you say either one of those, given or transitive property, that would be fine. Most of you would probably just say given, and that's good. But it could be a variation of the transitive property. Okay, step number 2, I'm going to do the other pair. So here's NP and here's SR. So now I'm going to say the other one, NQ, or in this case QN, is going to be congruent to TR, and that's for the same reason, either given or transitive. My penultimate step is that PQ and ST are congruent, also given. And finally, step 4, the 2 triangles are congruent. Again, we never ever put the reason prove down. The reason here is, according to my diagram, or according to this, I have a pair of sides congruent, a pair of sides congruent, a pair of sides congruent. So my reason here is side, side, side. So as we approach this next one here, we are told that O is the midpoint of MQ, and that O is the midpoint of NP. Now the diagram already marked that congruent, because it says that these have to be congruent and this has to be congruent as well. But we haven't written that down yet. So in a proof, we have to formally write it down, even if our diagram is all marked up. So over here, we're told that O is the midpoint of MQ. That's given information. Notice it didn't write down all the given. We're only using, we started with one given, and we're going to use that. So since O is the midpoint of MQ, specifically this, what 2 segments are congruent? Well, the MO and the OQ. So that's what I'm going to write down right here. MO is congruent to OQ. Next, the next given information is that O is the midpoint of the other segment. Learn to spell. I'm going to abbreviate midpoint here. So there we go, also given. And now, what segments are congruent? All right, so segment NO is congruent to segment OP. Just to follow along so that I have a pair of sides, and I did mess up, should say congruent there. A pair of sides here, a pair of sides here. Now notice we need a pair of angles, but which angle specifically? Remember, to use the theorem, side angle side, or the postulate, so in order to use side angle side, we do need these 2 angles. Now, folks, it's so much easier just to throw numbers down and use the numbers. You can use the letters if you would like, but over there, now in this case, when you're talking about it, it's there. Over here, it's already mentioned to you, so we don't have to worry about that. So MON and QOP, the angles. And what's the reason for that? Starts with a V. Vertical angles are congruent. Remember, the word vertical angles, or the term, only tells you what they are. It doesn't say that they're congruent. It doesn't go further. Now, according to the proof, I have an SSA. According to the proof, I have SSA. But according to my diagram, what's the pattern? SAS. Side, angle, side. So I tend to actually write my proofs in the order of what theorem I'm using, but it doesn't actually matter. The most important part is not that the S and the A and the S here are written in that particular order. It's just that you get all of them down at some point. Now, it is important that I put the midpoint first before I say the congruence, but it's not important that I put this side before this side or this angle after the other ones. So let's actually run through the whole proof on this one. Now that we've put some stuff down, I'm going to make the proof. All right, we already know by way of plan what we're going to use. We're going to be using side angle side. So I know my last step, I just don't know when it comes. So I'm not going to write it down yet. Okay, so statement and reason.